Maintenance of the stability and equilibrium of the body's internal environment from cells to systems is called homeostasis. Homeostasis is a dynamic condition. The continuous interplay and constant adjustments of the body's regulatory processes and systems function to keep our bodies in balance. Changes in the internal environment can vary from minor to significant and are categorized as normal limits, disruptions caused by temporary stresses, disruptions requiring medical intervention, and severe disruptions that cannot be restored and are incompatible with life. The equilibrium point can change over a narrow range, the body's normal limit, and continue to sustain relatively good health. For example, while a body temperature of 98.6 degrees Fahrenheit may be optimal, a change to 99.2 degrees would be within normal limits. Normal limits serve as the basis for medical testing. Medical test results are compared to these normal limit values to help determine if homeostasis has been disrupted. Stresses from both external and internal environments can move body condition away from normal limits. When stress on homeostasis is mild and temporary, the responses of the body cells quickly restore balance in internal environment. Shivering is one of the body's responses. When a stimulus or stress is more severe or constant, such as high fever or chronically high blood pressure, an underlying disease or disease disorder may be indicated. Medical treatment and intervention is often needed to return the body to homeostasis. If disruptions are extreme, the regulation of homeostasis may fail and death may occur. Communication between the body's cells, tissues, and organ systems is crucial to effectively regulate and maintain homeostasis. Two body systems, nervous and endocrine, play particularly important roles in fulfilling these major tasks. The nervous system provides a framework for sensory, integrative, and motor functions. The endocrine system secretes powerful chemicals called hormones that regulate body functions. A feedback system is a cycle that constantly monitors, evaluates, and adjusts the status of the internal environment of the body. A cycle is triggered by stimulus that alters a normal homeostatic state called a controlled condition. All feedback loops have three main components: a receptor, control center, and effector that communicates with one another to maintain a controlled condition. Most receptors are sensory nerve cells that monitor and communicate changes in the status of a controlled condition. The range of values for control condition, such as body temperature, is set in a control center. The input from receptors is evaluated and compared to normal or to norms by the control center. A plan of action for response to the altered condition is formed in the control center as well. Regular commands to affect the change in status of the control condition are communicated either to or in the form of electric nerve impulses or secreted hormones or both. Effectors are the cells of any body structure that receive output from a control center. Effectors produce a response that adjusts the altered controlled condition. Most of the body's systems use negative feedback system to maintain homeostasis. They're called negative because they reverse the altered controlled condition. For example, if a stimulus causes a rise in blood pressure, the feedback cycle will reverse this and lower the blood pressure. When a control condition is returned to its normal state by the feedback systems, homeostasis is attained. Positive feedback systems are fewer in the number because they reinforce an altered control condition that doesn't happen very often. Labor and childbirth is an example. A positive feedback loop can only be stopped by mechanisms from outside of the system, such as the birth of the baby.